And good morning, folks, and welcome to Build Stuff 2021, our hybrid event. We got a bunch of speakers on the ground in Vilnius. We got a bunch of speakers all over the world who are tuning in and sharing their wisdom and insight with us through the wonderful medium of internet streaming. And it is my great pleasure to welcome here on the Jupiter stage, talking to us about Kubernetes native Java. It's going to be Josh Long. How are you doing, Josh?
Doing well, thank you. How about yourself?
Yeah, very well. And you're joining us from 1 o'clock in the morning local time. Is that right?
Yes, sunny. Well, not so much right now, but sunny San Francisco.
Sunny San Francisco. Well, I hope you get sunrise a few hours from now. Anyway, please, folks, give Josh a big virtual hand. Josh, the stage is yours. Take it away.
Right on. Thank you ever so much, Dylan. I appreciate it. Good to chat with you. To everybody else, thank you so much for your time today. I appreciate that you have a lot of places that you could be. But you chose to hang out with us. As I am looking at the clock, it's 1:30. I was told I have 45 minutes, so that means 15 after. Is that about right, Dylan?
Yeah.
Basically-ish.
Yeah.
Okay, 15 after. So we have to go quick. That's not a lot of time, and I hope to cover a good deal more than I expected we had time for even before I realized it was only 45 minutes. So we're going to go quick. My name is Josh Long. I work on the Spring team. I'm a Java champion, a Kotlin Google developer expert, and most importantly, perhaps, I am at your service. So should you have questions, comments, feedback, tomatoes, whatever, don't hesitate to reach out to me, to find me on the intertubes. There are my various coordinates. And there's the code. So should you like to play the home game and follow along at your own leisure, your own discretion, you can find the code there as well. Twitter, LinkedIn, email, all that good stuff. I've got a podcast that comes out every Thursday. Well, Friday, your time, surely. But it comes out every Thursday, my time. I have a YouTube series, new videos that come out every Wednesday. That's this morning, really. It would have just released an hour and a half ago, my time. And I have a stream where the stream is not great. It's just me solving problems with friends. And then my blog, which is, it's, I don't know, you could probably do better, but it's not bad. So today, my friends, we're going to talk about Kubernetes native Java. And the whole point here is to write software that's intended for production. I love production. I think that all of us should love production. Production's awesome. Production is the place where our software lives. It's where our users are. It's where we build things that people want, and when they get to use that software. And so often as not, today's software, rather production, is Kubernetes. Kubernetes is an amazing environment that has coincided with the rise of cloud computing and sort of become the de facto standard for building infrastructure. And so I want to take advantage of that. I want to take advantage of this dynamic cloud environment. The problem is that I don't know why I want to take advantage of that dynamic cloud environment. That is to say, going to the cloud is interesting, but it's worth motivating why we care about that. And all things cloud and all things sort of modern tech, I think the underlying reason for so much of what we do these days is agility. How quickly can we take an idea and see that idea delivered into production where it can then benefit our users, and how quickly can we turn around based on the feedback, based on the validation and the cycle time, how quickly can we turn around and then improve that software and then start the cycle anew. That's important because it gives us a critical sort of capability that allows us to succeed in the marketplace. Speed is an existential threat to others in your ecosystem. If you can deliver software faster, you have an edge that most people don't. And so we look for ways to improve our organization. And again, just to stress, so much of what we talk about these days, so much of what we do and we think about these days has to do with speed. It's not particularly novel. It's not technologically unique. For example, continuous delivery, continuous integration, microservices, cloud computing, test-driven development, all this stuff. It's not like we didn't have a way to write automated tests before. It's not like we didn't have a way to deploy servers before. More importantly, what we have now is a way to do it quickly and in an automated sort of self-service fashion. That's interesting, right? That's interesting because it allows us to deploy, make mistakes, learn, rinse, repeat more quickly. I love all that. And we see organizations looking for ways to optimize their local sort of optimums, their maximum, trying to achieve their maximum velocity relative to their little context, their little corner of the organization. And of course, you might find the engineers looking at their code base and going, this is a large code base. There's a lot of us working on this code base. Surely we can do something to sort of reduce that, right? Because we don't need all of these people working on one giant code base. It might be easier if we could take logically distinct parts of the code base and break it apart, tease it apart into small batches that we then work on in concurrence, right? I can work on the customer service, you and your team on the order service, and them and their team on the profile service, etc. And the benefit of this is that we get autonomy. We can deploy things independent of each other rather than having to wait for everybody in the team to deploy, stabilize, integrate, test, and then validate changes into the code base for every single release. This is very, very useful because it gives us the ability, like I say, to move quickly. And so when you do this, what you want is independence, right? I want to be able to deploy this service independently of other parts of the organization. That said, when you're trying to deploy software, independently, you can't just link things together because otherwise you end up back in the same spot where you started. You end up having to try and synchronize all the release chains into one deployable unit. That's no good, right? What we want is the ability to deploy into production without having to wait for anything else, without being beholden to anything else in the organization. And so this naturally implies a service, right? You have a distinct network-based service where things can talk to that service to get their information. And in so doing, by building an application like this, you invite the complexities of distributed computing. You invite the fallacies. You run the risk of running afoul of the fallacies of distribution. The idea that the internet is infinitely fast, that the service will always be available, etc. These things are lies that we tell ourselves to sleep at night, but they are still lies. And so we need to write software that accounts for some of that inherent volatility. What we're going to do today, my friends, is we're going to write some software. I'm going to do so, as always, by going to my second favorite place on the internet. Obviously, my first favorite place on the internet is production. I love production, and so should you. But if you haven't been to production, you can begin your journey here at start.spring.io. And what we're going to do is we're going to build a new application here. We have some choices, my friends, some choices that we need to confront. First of all, night mode or, light mode. I don't know what this is called, bright or light. That's the first thing. For me, it's 1 a.m, so I'm perfectly happy to leave it there. But your local situation may change things for you. What do we want to name our service? I'm going to call this the customer service. I want to have an application. I want this to run in the JVM because, of course, I do. What version of the JVM? Well, you have some choices here, friends. You can use Java's 17, 11, or 8. But of these 3 choices, only 2 are actually valid. Java 17 is the current long-term supported version of Java. It's the only appropriate version on which to run your code today in 2021 as of 17 November of this year. The last long-term supported version of Java was Java 11, which is it's not an acceptable version with one caveat, which is to say you want to run your code on GraalVM, right? So GraalVM is an ahead-of-time compiler. It supports native image compilation. You can build architecture-specific binaries, and one way you might do that is with the Spring Native library, right? So Spring Native is a project that supports the metadata required to create an architecture-specific binary for your operating system, and that has some knock-on effects and benefits, things like much smaller footprint, things like a faster startup time, and so on, all of which are naturally great fits for the cloud. So if you want to do that, then effectively, even though they just released, I think in the order of like a few weeks ago, they just released a version of GraalVM that supports Java 17. For all intents and purposes, as Spring Native hasn't yet been updated to accommodate that, we're still stuck on Java 11. So if that's not your use case, then use Java 17. If that is your use case, use Java 11, but be prepared to update to Java 17 just as soon as humanly possible. In no scenario should you be using Java 8. Java 8 is woefully insufficient for what we're trying to do. It's out of date, it's slow, it's less performant, it's less robust, less secure, less syntax rich, less performant, less operations friendly. It is technically inferior in every conceivable way. It's also morally inferior in every conceivable way, given, compared to Java 17. You will not like the look of disgust and shame and frustration in your children's eyes when they realize that you're using Java 8 in production. Don't do it. Be the change you want to see in the world. Do the right thing. Use Java 17. Then we have to add some dependencies to support what we're trying to do. In this case, I want to build a reactive application that has a reactive web endpoint and the Spring Boot actuator. So I'm going to go ahead and hit generate, and that's going to give me a zip file, which I then want to open up in my IDE. And it doesn't all that much matter what IDE you use, so long as it supports what we're trying to do here. So in this case, Java 17, Maven, etc. That'll open up, in my case, in IntelliJ, at least I think it will. There you go. But Visual Studio Code works just fine. You can use the Spring Tool Suite. I mean, there's just any number of really, really good choices here. So don't feel constrained particularly. And our application is it's just a typical Spring Boot application. And we're going to build an application that writes data to a database. Let me make the font a little bit larger here, friends. I'll say that this is 22, hit apply, hit OK, good stuff. So what I want to do is I want to have an application that writes data to a database. So I'm going to create a record to describe my customer type, right? So customer, and I'll have a integer ID and a string name. Okay, and this integer ID is going to be a primary key, and I'll signal as much by using the @ID annotation from Spring Data. Then I'm going to persist instances of this entity in the database. So I'll say extends reactive code repository. Okay, code repository managing it's an integer, an entity of type customer with a primary key of type integer. This is a reactive code repository. So I'm using reactive APIs. You don't necessarily have to. Obviously, you can build applications that don't use reactive programming, but reactive programming brings with it 3 pronounced benefits. One of which is resource efficiency. That is to say, reactive programming gives you a way to describe the flow of data in a stream. And then it allows you to apply that stream of mutations to in a particular context, basically a thread or a thread pool, a scheduler. What that means in the concrete terms is you describe how you want things to be done, and you give the runtime clues about when it can free up the thread on which you're executing. And you do this usually by using something asynchronous. If you are willing to write code in such a way that you do that, the runtime can then move you off of the main thread when you're in a wait state, when you're waiting for something to happen, such as bytes that you've asked for to arrive. If you do this, if you write code in such a way that you're constantly giving the runtime a clue about when you're not using the thread, then it can make sure that you're never sitting on a thread doing nothing, monopolizing that thread so that somebody else in the system can't use it. That's a big deal because it means that now you have much, much better scalability. So much of what we do when we build distributed systems is input and output, the communication between one service and another, between one piece of infrastructure and another. And if you can remove that wait time, if you can just get in there in between the raindrops and allow the threads in your system to do other work, your scalability goes up considerably. Reactive APIs aren't about making any one transaction or any one particular request faster. It's more about allowing you to handle a good deal, many more transactions per virtual machine, per computer, per node, etc. One symptom of a system that's doing a poor job of this is that when you log in and you check top and you see that your CPUs are all idle, and yet you're not able to make more requests because they're all in some sort of wait state, waiting for something that isn't going to happen to happen. This is the worst of all scenarios because you've got this expensive, beefy piece of infrastructure, this hardware, this server, this computer, this AMI, this whatever, and yet it's going completely to waste. And you can't do anything about it save for restarting the service. So reactive programming should help you fully, maximize your use of these of this infrastructure. The next benefit that you get is that by using this Reactive Streams API, you have a single abstraction with which to describe your state transitions, your state, your streams of data. Because you have a single type, you have some knock-on benefits that come out of that, right? One of which is that your composition becomes much easier. You have a single abstraction that you can use to describe all data. It doesn't matter if it's just like 5 records that all come very quickly, or if it's an infinite stream of records that'll happen over a while, like sensor data or feed, data or stock ticker updates or whatever. It doesn't matter if it's large amounts of data, slow amounts of data, small amounts, large, slow, fast. It doesn't matter, right? It's the same abstraction. So you want to talk to Apache Kafka? Great. Want to talk to a REST endpoint and get 5 records back? Great. Want to do WebSockets? Great. Want to do, whatever. It's all the same abstraction. And that eliminates so much of the busy work that we have to do to adapt one API to the other when we build distributed systems, because you have, so much of the tedium, the glue of building distributed systems at scale these days is adapting one data source's lifecycle to the other, right? Let's suppose I wanted to get data from a Kafka queue and then send that on to a client consuming it via WebSockets. These are not the same API. They don't even look like the same API. But essentially, they're just streams of data that describe data that arrives eventually, right? You don't know when. It's not all going to happen right now, but you might have a record now. You might have another one in 5 hours. So they're both reactive streams. And because they're both reactive streams, so much of that glue code just goes away. So reactive programming makes composing data very, very natural, because you can throw away in your head all that knowledge you've built up around these other kinds of APIs. The third benefit you get is because you have a single abstraction, you have a natural place in which to interpose things like operators for reliability and retries and timeouts and back pressure. Back pressure is this concept that the consumer of the data is in control of the rate at which it consumes that data. This is critical because now you can't overwhelm that consumer. It can push back. It can say, no, thank you. I don't want any more data. Thank you so much, but no. So reactive programming is very cool. It's powered by something called the Reactive Stream Specification. There's a library that builds on top of that called Project Reactor, which provides two interesting types, mono and flux. These are both reactive streams types, but they sit on top of the publisher type. So now I've got this basic repository, and now I want to build an HTTP endpoint that serves up that data. So customer REST controller, private final customer repository. Okay, and we're going to inject this into the constructor, thusly, and we're going to say I want to return all the customers. Okay, customer get this dot customer repository dot find all, and this is going to be an HTTP API. So I'm going to signal that it's not an MVC view kind of thing. The next thing I want to do is I want to create some data in my database. So I'm going to just do take advantage of a little convenience here in Spring Boot. I'm going to create a file called schema.sql, and I'm going to create my SQL table. This is an in-memory SQL database, so I need to make sure that I have a database to which I can connect, and that database needs to be initialized with a schema. Otherwise, where will my data go? So I'm going to create a field here, varchar 255 not null. Whoops, the Zoom window's right in my way. Look at that, go away. Okay, there's this, and then I need some data. So we'll initialize that. We'll say insert into customer name values, and we're just going to put some people on the Spring team. So Josh, I'm Josh. Nice to meet you. Stefan, we've got Olga, we've got Madura, we've got Yushin, we've got Violetta, we've got Spencer, and we've got the good Dr. Sire. He's one of my favorite doctors, along with Doctors Who, Sue Strange, and so on. All right, so there we go. There's my basic HTTP REST endpoint. Let's go ahead and see what that does, and I'll take a drink. I think I've earned it. Actually, that was the last sip of that drink. That makes me sad. Okay, application's up and running. Life is good. Let's see, localhost customers. Yeah, there we are. Fine, it worked just great. Is that what we came here to do? Certainly not, right? That was always going to work. That's not why we're here. That's an application that serves data, but is that what we need to go to production? I think not, right? We want to support visibility into what our application is doing. And we can do that through the actuator. The actuator are a set of managed HTTP endpoints that are brought in by this module. And we can see things like the health probe. So I want to say probes enabled equals true. I want to show the health details always. So I'm going to go ahead and restart this application yet again. Compile. Okay. And there we are. There's my application again. And if I go back to the actuator here, /actuator, I get a number of endpoints. And these endpoints, some of which are there's many endpoints. Some of them are self-explanatory. The beans endpoint shows you all the different Spring Beans, their scopes, the class literals, the dependencies, etc. The caches endpoint shows you all the Spring Cache Manager implementations, of which we have 0 at this point. The info and health endpoints we're going to return to in just a second. The conditions endpoint shows you all the different tests that were run at startup time to the results of which produced the application that eventually congealed into the running state that you see before you. The config props endpoint shows you all the different properties to which Spring Boot will respond, and if they've already been specified, what those values are. So for example, you saw me specify management.endpoints.web.exposure.include back here. That's up here, right? I specify that, and it's equal to asterisk, and so you can see that here. The env endpoint shows you all the system properties, environment variables, and the environment of the running machine, of the node on which you're running this application. The loggers endpoint shows you all the loggers and their log levels. You can post to this to update the log level of a running logger while the service is running. The heap dump and thread dump, respectively, give you heap dumps and thread dumps. The metrics endpoint gives you statistics, things like how many requests you've seen and so on. And that in turn is powered by something called Micrometer, which is a abstraction for time series databases, including but not limited to AppOptics, Azure Monitor, Atlas, Prometheus, Google Cloud Stack Driver, StatsD, and of course, VMware's own Wavefront. Disclaimer, I work for VMware as part of the Spring team. Okay, good stuff. So we got the micrometer, and we've got the scheduled tasks and mappings. Now, mappings shows you all the different HTTP endpoints that are surfaced and visible for consumption in the outside world, their predicates, the handlers, etc. Now, we said we'd return to both info and health. Info is it's a natural place in which to put information about the application, things like the ID of the application and any particular thing that you want to be able to use to identify the service in production. So one way I can do this is just to say info dot, let's say message, hello world, right? Or hello build stuff. Okay. So that's one thing you can do, and that would certainly work. But a very useful thing you can do instead is also, let me see here. You can also get the information about the build itself, the git commit ID that triggered the build rather, up and running. So let's see here, go here, and voila, there's my message. Let's go ahead and stop this application. And I'm gonna go to the command line. I'll say git init, git add, git status, git add, git ignore, git add dot maven, git commit up. Okay, so now I've got a git repository. I'm gonna say maven skip test equals true, clean package. Okay, goody. So now if I restart this application, and you can see, oops, I need to synchronize here. Oh, I need to actually add a build plugin. I forgot about that. So I want to show the information related to the current build. I'll add this plugin here. Voila. Okay, very good. Plugins. There we are. Okay, so I'm just opting in to this one little plugin. It's already been configured for me. I'm just adding it to my build so that I can use it. All right. So let's stop this. Rebuild. This time it'll take a little longer. There we go. Restart. Goody. So now if I return there, I get the commit, the branch, the commit ID, the timestamp, and so on. So if you're doing continuous delivery, you do code, git commit, git push. It goes into a CI environment. CI environment, you build the jar. You might use something like build packs to easily create a Docker image, or in our case, you can just use Maven Spring Boot build -image, and that'll use build packs for you, and that'll create a Docker image that you can then Docker tag and then Docker push to your container registry of choice, which will then trigger the continuous delivery pipeline. You might be using something like Argo CD or Flux CD, and that'll then take your container and update the tag for that, and then that'll trigger a reapplication of all the YAML files for your system, for your Kubernetes, resources, right? And that'll invariably pull down the latest container if you say, you want to always pull down the latest one. So that results in a change in production. You make a change here, it goes straight to production almost immediately, right? A few minutes later. So it can be very useful to have this endpoint to show you what version of the code is running there. So you can do git bisect and so on to sort of go about remediating it if you have something that you need to fix. So I like that. I also like the health endpoint. The health endpoint shows me all the different subsystems in the application that, were they to fail, would imperil the state of the overall service. So things like the file system, the health checks, and the connections factories, and so on. You can create your own health checks. You can also work with Kubernetes probes. So here we've got some probes around liveness and readiness. Liveness is whether the service is still alive. Readiness is whether the service is ready to be put into production. So readiness gets checked when the application starts up. If it's okay, then it's put into production. And liveness asserts whether the service is still worthy of production. If these endpoints should ever come back as down, if they should ever say down, then this endpoint will return a 500 error. It won't be a 200 error. And then the container orchestrator, Kubernetes in this case, is going to destroy your pod. So the question then is, what happens? Well, normally you get a sig term signal. The sig term signal tells the application to shut down, and then it gets followed by a sig kill, which is a forceful sort of killing of your pod. The question is, what happens if you have any in-flight transactions, if you have any in-flight web requests and so on? Well, in that case, you want to enable graceful shutdown, right? Graceful shutdown means that it'll stop accepting new requests, and it'll give you a configurable period, an interval, before it actually shuts down. So I can say, I want to use the timeout per phase of 30 seconds. And you need to make sure to configure that in your corresponding pod or deployment resource, YAML description. Once you've done that, now your application will stop doing new requests, and you can finish any in-flight transactions, assuming it fits within 30 seconds, of course, and hopefully avoid dropping state on the floor, important state on the floor. Now, this is a lot of configuration, some of which is very specific to Kubernetes. So Spring Boot has a way in YAML files to segment off different profiles of configuration. We also have that now in property files. And so here I can say, everything after the --# is unique to Kubernetes. And the way I do that is I activate it based on a cloud platform. So cloud platform equals Kubernetes. And there I can actually put configuration that's specific to Kubernetes, like, for example, this and this stuff right here, right? So maybe that's all configuration for only Kubernetes. And I can test that. I can test the configuration by, let's say, putting a random, different server port. Okay, so 8082 instead of 8081. It should show just 8080 at the moment because it's not configured to think that it's in Kubernetes. So let's see what that looks like. Yep, it says it's on port 8080. I want to run this now on, I want it to think it's running in Kubernetes. So I'll say main cloud platform equals Kubernetes. That's a property that you can specify either as a property file value or as a program argument. So I can say environment or program arguments -- blah, blah, blah. Okay. And then restart. Okay, so there we go. It's going to start up on port 8082. And that's working, right? We're getting configuration there. I can also do this in my Java code. I can say customers applications at bean application runner. Okay, return new args, blah, blah, blah. And I can just print out hello Kates. Okay, so there's my very simple Spring Bean. I want this to be conditionally running on a, when it's in a cloud platform of interest, in this case, Kubernetes. So I can just add that conditional on definition there. And this will only get invoked when it thinks it's inside of a Kubernetes context. So if I change this, edit configuration, get rid of that, hit apply, hit OK, voila. Okay. Good. So there, it's not there anymore because it's no longer in Kubernetes. Now, what if it is inside of Kubernetes? I might want to get configuration from a config map. And a config map is a directory. It's a dictionary of keys and values. And those keys and values can be exposed to your application via one of 2.5 ways. The halfway is you can write code that talks to the Kubernetes API directly. That's a little bit of a cheat because it's pretty insecure. You have to have permission to talk to the API server from your running pod, which may not be what you want in production. So the other two more fruitful approaches, the more useful approaches, involve either taking the config map and exposing it as your environment. You can use it to populate the environment variables that are exposed to your application, that would just work. So Spring Boot already knows about what to do with environment variables. Or you could put it in a config tree, and a config tree is a directory in which the files are the names of properties. So I could say echo 8084, and I'm going to write it out to a property file, or to a file called server.port. So 8084 is a property. The file is called server.port. If I then want to import that config tree of configuration, which is certainly within the realm of reason, I can say import config tree home desktop. In this case, I've just put that on my local machine, but of course that would be in your Docker container somewhere, more typically. Okay, so there you go. So you can see it's now started on port 8084, not on port 8082. So it read the external configuration that had an overriding effect on this value here. Okay, so now you've got a microservice. It's up and running. There's lots of integrations with Kubernetes and so on. We didn't even get a chance to look at Spring Native here. Spring Native is a great way to take your applications and turn it into GraalVM native images. But I want to move on. So we're going to go back to start.spring.io. And here, I want to build another microservice called the profile, profile microservice. And this is a service that I'm going to expose. It's a service I'm going to use something called RSocket with. RSocket is a binary protocol that was created by engineers at Netflix and Facebook that is designed to get around some of the substantial limitations of HTTP 1, HTTP 2, gRPC, etc. It's just really nice. It's a binary protocol. It's not HTTP. It's just there's a whole lot we could talk about here. But suffice it to say, we have built-in support in the Spring ecosystem. So I'll say record type is profile. I'll have an integer for the ID and another integer for the customer ID, right? And this is you can imagine for each customer, there's a profile associated with that. So I'm going to say profile RSocket controller. And it's just another controller as before. And I'm not going to bother with an in-memory database. So I'll say, create the constructor. And I'll just create a mapping here, map of integer ID to profile DB. Notice I'm using air quotes here when I say DB concurrent hash map. Okay. And map. And what I want to do is I want to say, okay, for var customer ID equals 1, customer ID is less than or equal to 8, customer ID plus plus. This.db dot put customer ID new profile. Okay. And the ID will be on the, we're going to increment that. We'll say var ID equals 1. And we'll say ID plus or equal to 1. And voila. So customer ID on the left, I suppose they're actually the same value. In this case, it would have been fine, but you get the idea. I'm going to have one for each record, one for each type. Okay. So this is my basic constructor, my controller. I want to make that accessible. So I'll create an RSocket endpoint using the message mapping annotation. I'll say, given a request for the profile ID dot customer ID, I want to return a particular profile. So I can just say profile, get profile for customer. And I'll pass in the destination variable, integer CID, return this.db.get CID. Okay, so there's my basic thing. Now, in order for this to work, I need to have an RSocket server running somewhere. So I'll spin that up. Okay, so now I've got an RSocket service. I want to talk to that from the edge. And an edge service in your microservice architecture is a logical first port of call for requests intended for your downstream services, in which you can address a couple of common scenarios. One is you might have different clients that have different constraints that need to be accommodated. And rather than introduce accommodations for those different constraints, like bandwidth constraints or quirks in the protocol handling or different kinds of security or different integrations with different marketplaces or whatever, rather than accommodating each one of those nuances in those clients in every single downstream microservice, which would be tedious even if all your services were completely homogeneous. But in this case, one is RSocket, one is HTTP. So now it borders on, nigh on impossible. Rather than do that, you can actually just centralize some of those concerns only so long as they don't stop you from remaining independent or autonomous. So we're looking for low ceremony, low friction, general cross-cutting kinds of concerns, right? Not business logic per se, more about glue code or filters or things that can be applied to your pipelines of data without affecting it. So, this is a edge service. We're going to use Spring Cloud Gateway. The other use case that we can apply here is to consistently apply things so that we get a consistent level of quality of service, right? So for example, if I want to do routing or security or whatever, rather than redoing that for each microservice, I want to do it once and I want to do a very good job there, right? So I'm going to use Spring Cloud Gateway. I'm going to use the reactive web support. I'll use RSocket support. And I want to also bring in the GraphQL support, but it's not here on the initializer just yet. So we'll generate it and we'll just add it ourselves manually, the old-fashioned way. So UAO edge.zip. Okay, so now I've got a brand new application. And the first thing we're going to do is we're going to look at Spring Cloud Gateway. So this will be running on port 9191. Why is this upset with me? Okay. RMRF edge. Okay. UAO edge.zip. Sometimes it forgets that I have a JDK, which is super not great. Edge up. Okay. Maven clean package. Nope, no issues there. Open module settings, project, hit apply, hit OK. Okay, we're good. So now, what I want to do is I want to build an application that uses Spring Cloud Gateway. Spring Cloud Gateway is an API gateway that has a very simple DSL that you can use in Java, or you can use through YAML files or the property file syntax. I'm all about that hashtag no YAML life, so I tend to avoid it whenever possible. But if you want to do that, then there are some benefits there, not least of which is that you can then version control your YAML files or your property files in a Git repository, and then use that as the backing for a Spring Cloud config server. Okay, and then that can in turn be reloaded live. You can reload the configuration without restarting this gateway service. So each Spring Cloud Gateway app has a predicate that matches incoming requests. So I might say that the host header has to be wildcard.string.io, and it has to go to proxy. And then I'm going to send it on to the downstream microservice called customers. Now, the problem is I'm going to match the incoming request with this predicate, which means that the path will already be proxy. So I need to change that. And I can do that here. I can say, change the path to be customers. The filters are where the magic in Spring Cloud Gateway lives, right? I can do requests and retries and redirects and routing and rate limiting and all sorts of stuff here. But for now, that'll just have to do. Let's go ahead and start this. Terminal.
Got about 5 minutes to go, Josh.
Oh, I thought we agreed on 9 minutes. 15 after.
You can probably have 9 minutes.
Thank you. Okay, so customers. Sorry, not customer. 9999 / proxy. Yeah, and the host header is host hi.spring.io. Is it not on this port? Oh, server port equals 9999. Eccolo. Okay. Good. Take two. So there's our JSON. If I tested this with hi.spring.com in the vhost, it gives me a 404. So Spring Cloud Gateway is great for creating proxies and applying filters against that data. Great. Okay, the next thing we want to do is to compose the data from downstream. You might have a client that is roaming and it's on 3G and it's you can't create a lot of threads, whatever. There's a lot of reasons why you'll have trouble, but suffice it to say, it makes no sense to make the client do all this service orchestration, scatter gather kind of composition when we could do it ourselves. So I'm going to create some records to describe the customer, and I'll create another record here to describe the profile. Okay, and I want to then consume all of this stuff as a composite type. So customer profile, customer on the left and profile on the right. Okay, good. And what I'm going to do is I'm going to call each microservice and get the data as I need them. And in order to do that, I need to use the reactive non-blocking HTTP client. Okay. And I want to use the reactive non-blocking RSocket client. And I'll add this to the constructor as well. Very good. And it's just going to be a regular Spring Bean. And in order for the Spring Bean to do its work, I need to look up all the customer data. So I'll say get customers, return this.http.get.uri, HTTP localhost 8080 / customers. And I'm going to say I want to retrieve the data and turn it into a reactive stream of flux. For the order data, for the profile data rather, I want to say get profile for integer customer ID. Okay, so parenthesis, return this dot rsocket dot route profiles dot CID, passing in the customer ID, and then I'll say return a profile. Okay, so I'm making a network call here, and I want to consume both of those to get the customer profile data. So let's do that. We'll do some service orchestration to make this work. So customer profile, get customer profile. I'll say return this dot get customers dot what do I have here? I have a customer, and I want to take each customer. I want to keep in memory the customer and the profile information. Mono dot zip. The customer will be on the left, okay, and the profile on the right. So get profile for customer.id, and then for each one of those, I have a tuple, and this tuple gives me information like the customer and the profile. So I can use that to create this aggregate type, this composition of both types, and yet I'm actually running the most efficient version of this code. It's service orchestration and composition. It's let me see, map, is it? There you go. It's reactive, non-blocking, concurrent, multi-threaded code, and yet you don't see this being burdened with a cyclic barrier, countdown latch, or whatever. So CRM risk controller, private final CRM client, CRM. Okay, and we're going to just return this to make sure it worked. Publisher of customer profile, get return this.crm.get customer profile. So let's just start this up just to make sure it's working just fine. Now, I'm happy with that choice, but I do want to use GraphQL to solve some of the issues. Oh, look, I need to actually define these clients that I've just been using. So let's do that very quickly. Hopefully that'll give us a few seconds here, or take it rather only a few seconds. So builder.build, good. What about the RSocket stuff? Good. So builder, turn builder.tcp, localhost 8181. Very good. Let's restart this. Okay, so localhost 9999/COs. Something just went very sad and wrong. Localhost. There's no such thing as localhost. Where is that localhost happening? Here, localhost. Oh, here, localhost. It's not a crazy host. It's just a host. Okay. Very good. So there's my application now. It's spun up, refresh, and there you go. I got the data from both the customer profile data at the same time. And this works great for now, but let's suppose I want to change the data or change the client. Well, in this case, I need to build a new edge service, and that's tedious. So this is the same exact conflict that Facebook had back in 2012, and they created GraphQL, which is a way to sort of build an API endpoint that the client can tailor the data. It can request the data that it wants and get back just that data and no more. So I'm going to bring in the repositories, the snapshot repositories here, and I'll bring in the GraphQL Spring Boot starter, like so. And with that in place, I'll hit refresh. Now GraphQL requires a schema. So I'm going to go ahead and create some schema here. And that'll be GraphQL. I'll create a new file here called schema.graphqls. And in there, you've got the root type for all GraphQL applications, and that'll be a type called query, where I'm going to enumerate all the customers. Now, the type for a customer looks like this. It's the same as we saw in the Java code. And those customers, in turn, have profiles, don't they? So I'll say profile, and the type for a profile looks like this: ID, and customer ID. So now I've got three different types. I want to build the handlers to support those types. Okay, so I'm going to build yet another controller. You've seen me write controllers for RSocket, for GraphQL, and for HTTP. So CRM GraphQL controller, and I'm going to create an endpoint here. It's called schema mapping. The type name is query, and the field will be determined by the name of the method here. And in order to produce that, I'm going to inject the CRM client Okay, and we'll say return this dot crm dot get customers. Voila. And what about the profile data? Well, I'll say schema mapping type name equals customer, right? And the type that we expect back is a profile, get profile, and of course, where do we get the profile from? Well, the customer. So I'll say inject that root type, customer.id, and voila. Okay, so now I've got these two different GraphQL endpoints. Let's go ahead and restart that, and I'll finish up hopefully with a few seconds to spare here. Okay.
You actually have a bit more time than that, Josh. It turns out we've got a schedule that says you have an hour, and we've got a schedule that says you have 45 minutes.
Oh, good gravy. Okay, well,
my apologies there for the confusion. Certainly take another couple of minutes. The next session on this track is up at 12:30, and there's a coffee break scheduled for 25 past. So if you want to take another 5 minutes or so to get some stuff running, that's absolutely fine.
You're amazing. Okay, so we've got our GraphQL endpoint here. This is the same GraphQL console, GraphIQL console, as for example, as you'll see when you use API at .spacex.graphql. And in GraphQL, you have three very simple concepts: the concept of a query, the concept of a mutation, and the concept of a subscription. A query is a way to read data, a mutation is a way to update data, and a subscription is an ongoing query, basically. It's like sensor data or feed data or whatever. The nice thing about GraphQL is it's just very simple. It's unabashedly focused on one thing, which is getting data, from and to the server via the different clients. So if you want to update data, there's no discussion around whether it's HTTP put or post, or there's no discussion around whether you're doing delete or if you're doing 201 or 200 or 202. It's just using mutation. That's it. And yes, I'm using HTTP here, but it's almost accidental or incidental. Certainly, I could have used WebSockets. In fact, that's supported out of the box, and I would love to see personally WebSocket support one day as well. Okay, so I've got a GraphQL endpoint here. It's very, very convenient, and you can see, like, if I want to use the SpaceX query, right, I can just ask for the mission information. Great. I want the IDs as well. Great, that comes back. I want the launch date. Great, and I'm getting the data that I want, and no more than the data that I want. So if there are implications for accessing this other data, such as a network call that needs to be made, I don't pay that cost unless I ask for that data in the first place. So let's go back to our query, and I want to get the customer data. Great. Okay, there's that. There's the name data. Great, that seems to be working. What about the profile? Remember, that results in a network call. That seems to be failing for reasons. I don't know why. The field name is called profile, not get profile. So let's restart that. Take 3, and there we go. Profile is equal to 1. What about the customer ID? Okay, there we go. So now I've asked for the customer data. I got it all back. I got the IDs, the names, and then I decide, hey, you know what? This particular view needs the profile data. I can ask for that as well. So GraphQL is great because it scales up and with your clients. And so if you want to just show the search results, great. Just ask for the customers. You can pass in parameters and do all that and show the ID and whatever. If you want to show the details, you can load the whole profile just by changing the query. And it's the same API endpoint. So now you can jettison a lot of the complexity associated with building out all these different edge services. My friends, we've only begun to look at some of the patterns that you should keep in mind when writing services intended for production, where these days production is Kubernetes. Obviously, there's a lot of stuff we could be doing beyond this. There's actually a project called Spring Cloud Kubernetes, which provides APIs that let you work with Kubernetes in terms of the API server. So again, you need to have access to that API server. You need to have that permission, the RBAC permission in your Kubernetes cluster. Really interesting possibility though, and you can do some very interesting things like dynamically reloading the configuration in your application whenever a config map changes externally, right? You don't need the config server for that anymore. You can just change the config map directly by doing kubectl apply, and your Spring Boot microservice will automatically update its configuration. That's one thing. You can also do service discovery using the Kubernetes API server as well. That's one possibility. Another possibility that's really interesting that I've explored in other videos is using Spring Native, which is it's how you create GraalVM native images, which are super lightweight, super fast, start up in 100 milliseconds, that kind of thing. It's how you can use that API to create a Kubernetes operator, right? So you can talk to the Kubernetes API using Spring and using all the infrastructure that Spring brings with it, and then compile that to a native image, and then deploy that native image into your Kubernetes cluster as an operator that acts on changes in your cluster. right? As all Kubernetes operators do. So some really interesting opportunities that go beyond what I've shown you here. I thank you for your time. I wish that we could be there together in person, but circumstances are weird. Maybe next year. And thanks again for your attention.
Thank you so much, Josh. That was excellent. I love a session with a lot of real hands-on live coding and pulling things together, actually showing how it all works and stuff. So that was awesome. Folks, we are going to drop, if you're watching this live on Pine, there is a link going in there now. This is the Zoom room where we are going to be doing questions and answers. Josh, I'll stick that link here in the Zoom chat for you as well, just so you can jump on over there. So Josh, a couple of other speakers and folks with questions, please head on over there, ask questions. I'm sure Josh would be more than happy to answer all of your nitty-gritty questions about Kubernetes and Spring containers and Spring Boot and all that kind of stuff. I believe we are going to take a short break. We will be back on this stage in 10 minutes with Oren, aka Ayande, going to be talking to you about how to build a database from scratch. So we'll see you back here in 10. Thank you very much, Josh. As you said, it would be nice to do this in person. Perhaps next year we can all get together in Vilnius and do this face-to-face. But in the meantime, thank you everyone for tuning in. Thank you very much, Josh, for speaking. You can go and answer some questions and then get some sleep. I nearly said you can go and get some sleep now, but not quite yet. I'm sorry. But great stuff. Thanks for joining us.
I'll see you all there.
See you shortly, folks. Take it easy.